Solve the following trigonometric equation. 3 into 1 minus sine x is equals to 2 cos x squared, isn't it? So if you look at this trigonometric equation, they want for all values of theta between 0 to 360. Now here, you can see, for you to solve it, everything must either be sine or everything must either be cos, isn't it? So here, we have cos squared, meaning we can get rid of cos squared using Pythagorean identity, isn't it? So that everything is in terms of sine. This sine is not squared, there is no identity which applies there, isn't it? But this cos is squared, there is an identity which applies to that, isn't it? So you know very well that Pythagorean identity, cos squared x plus sine squared x is 1. So this implies what? It implies cos squared x will be 1 minus sin squared. So where there is cos squared x, we put 1 minus sin squared x, isn't it? So this side of the equation we have 3 into 1 minus sin x to be equals to 2 into cos squared x, which is 1 minus sin squared x. Then I want you to look something here. This is 1 minus sin x, this is 1 minus sin squared x. What does that mean? This is a difference of 2 squares. Have you seen that? This is a difference of 2 squares because it is like a squared minus b squared, which is a plus b into a minus. Are you seeing that? So if you have 1 minus sin squared x, that is 1 plus sin x into 1 minus sin. Because 1 is the same as 1 squared, so you can see your a is 1, your b is sin x, isn't it? So this is a squared minus b squared. Are you seeing? It is a plus b, which is 1 plus sin x, and a minus b, which is 1 minus sin x. I'm writing in that form because I saw in this side of the equation we had 1 minus sin x, meaning you don't need to go to details of forming a quadratic equation, whereas you can actually get that difference of 2 squares. Are you seeing that? Are you seeing that in this problem there was no need of a quadratic equation? But it means when we did not have this term 1 minus sin x, then we were to form a quadratic equation, isn't it? Are we together? Yes. So here there is no need of a quadratic equation because this is a difference of 2 squares, meaning giving us one of this, isn't it? So here we have 3, 1 minus sin x to be equals to 2 into 1 minus sin squared x we found is what? Is 1 plus sin x times 1 minus sin x. So you can see you have a single term on either side of the equation, isn't it? Are we together? So it means this 1 minus sin x cancels with 1 minus, isn't it? So what do you remain with this side? 3 to be equals to 2 into 1 plus sin x, isn't it? Are we together? So what do you get here if you simplify? Simplifying this is simple. 2 times 1 is 2 plus 2 times sin x is 2 sin x. What is outside the bracket multiplies everything inside, isn't it? So here you have 2 sin x is equals to 1, isn't it? See, you bring 2 this side of the equation. So you have 3 minus 2, isn't it? You get 1 is equals to 2 sin x. So you can start with the 2 sin x to be equals to 1, isn't it? Are we together? Yes. So for you to get sin x, you divide both sides of the equation by 2. So this implies that sin x is equals to a half. That is 0.5, isn't it? So for us to get x, what do? We look for the sine inverse of 0.5, isn't it? So x is going to be the sine inverse of 0.5. So remember, this 0.5 is positive. That positive is only telling you the quadrant where you are going to deal with, isn't it? So you look for what is x. Simply look for the sine inverse of 0.5. After you found the value, the sine is telling you which angles do you want, because the angle must be in 4 quadrants. If you draw that you are 4 quadrants, all students take calculus. So the first angle is theta, the second quadrant is 180 minus theta, the third quadrant is 180 plus theta, the final quadrant is 360 minus theta. Are we together? So what is the sine inverse of 0.5? 30 degrees. So that 30 degrees is not the answer of x. That 30 degrees is the angle in the first quadrant. Are we together? The angle in the second quadrant is 180 minus 30. 180 minus theta. 180 minus 30, that is 150. The angle in the third quadrant is 180 plus 30. That is 210 degrees. The fourth quadrant is 360 minus 30. That is 330 So which solution do you want? You want the quadrant where sine is positive because this 0.5 was positive. Are you seeing that? This 0.5 was? So which quadrants are the sine positive? Sine is positive in the first quadrant because in the first quadrant all of them are positive, meaning you need that angle 30 degrees. So that is the first solution of x. Are you seeing? The second quadrant only sine is positive, meaning you need that angle 150 degrees. The third quadrant only tan is positive, meaning sine is negative there. You don't need that angle. You only need angles where sine is positive. Are you seeing that? The final quadrant only cos is positive, meaning sine is negative there. You don't need that angle. So which angles do you need? 30 degrees and 150 degrees. And after getting all the solutions, you now select the ones between 0 to 360 degrees, and you can see both of them are between 0 to 360 degrees, meaning this was not theta, that was x, isn't it? Between 0 and 3, so you can see 30 degrees is between 0 and 360 degrees, isn't it? 150 degrees is between 0 and 360 degrees, like that. Are we together? Yes. So that is how to solve that given problem. So it means when this was not a difference of two squares, you were just going to simplify it, then you make it in form of a quadratic equation, isn't it? Are we together? Yes. Good. That is how to handle that problem.